So as we have seen what is covariance and how do we calculate the covariance. So now it's time to look into the types of covariance. So there are two types of covariance. So covariance can be either positive or negative. So it can be classified into two sorts based on this. So the a positive covariance is between two variables, indicates that they are heading in the same direction. The variables in this case behave similarly. That is, if the values of one variable, more or smaller, correspond to the values of another variable, they are said to be in positive covariance. And second one is a negative covariance. Um, when two variables have a negative covariance, the variables shift in the opposite direction, inversely proportional. It's the inverse of positive covariance, in which higher values of one variable correlate to lower values of another, and vice versa. Again, I'm repeating, if it is positive covariance, uh, if the values of one variable, more or smaller, corresponds to the value of another variable, they're said to be in positive covariance. On the negative covariance, higher values of one variable correlate to the lower values of another, and vice versa. So applications of covariance, the if let's see some of the applications of covariance. Simulating systems with multiple correlated variables is done using Cholesky decomposition. A covariance matrix helps determine the Cholesky decomposition because it's positive semi-definite. The matrix is decomposed by the product of the lower matrix and its transpose. And second one, to reduce the dimensions of large data sets, principal component analysis is used. To perform principal component analysis, an eigen decomposition is applied to the covariance matrix. So now the question arises, what is covariance? So what is a covariance matrix? A covariance matrix is a square matrix that illustrates the variance of the data set elements and the covariance between two data sets. So variance is a measure of dispersion defined as data spread from the provided data set's mean. So covariance between two variables is calculated and used to measure how the two variables fluctuate together. Yes, we have seen enough. Now it's time to do some calculation of covariance. So I'm going to type this as covariance. It's 1. So I'll take the same data. So let me bring it from here. So create a sample data set. I'll take the same data. Okay, not this one. Let me take the top one. Yeah, this sample data set. And we know that this is negative correlation, so I'll put it as CV, and this is what our data set. Now let me calculate the covariance between x and y. Calculate the covariance between x and y. So covariance is equal to df x dot covariance cov d sorry dfcv and covariance of dfcv of y. That's it. Okay, there is some issue. Data frame object is not callable. Sorry, that's my mistake. Yep, the covariance has been calculated for this. So now let me print it. So covariance between x and y, that's covariance. It's minus 2.5, and the correlation is minus 1. It just gives the relation, and it also gives the how much it's gonna change. If one changes, it's minus 2.5. So let's do the same for second type of data also. So let's take this data, we'll do the minor changes. Okay, we know this is a positive correlation and how the value will change here. So DFCB, and I'm gonna change this to covariance. Let me bring this formula from here. Exactly. So rest all remains same. DFCB, everything remains same. Let me execute, but the code only changes. It's 5.0. It's fantastic. The covariance is 5.0. So that's the change. If one this increases, other also increases. Here, if this increases, other decreases. So negative covariance. Let's look for the third one. That's the no variance. Sorry, no correlation. Let's keep it same. Everything, nothing to be touched. So here I'm gonna take the covariance from here, and let me paste it here, and rest all remains same. Execute, it's 9.4. So that's what they're just talking about the change. Here it doesn't talk much about the correlation. It's just talking about the covariance. Let me re-execute this. So this is our DFCV new data frame. Let me cross check. DFCV, yes, correct. So it's just talking about the covariance. This is just positive. Okay, the variance at any way it will be there. The variance will be there, but how much is gonna vary is the value that we're gonna get. Okay, that's what the correlation and covariance for us.